Okay, so now this video considers a small amount of information regarding oceanography and the patterns of the currents. Those are observed in the oceanic realm. The oceans are vast expanses which we know, and mostly those are covered by the abyssal plains or the upper parts of the oceanic crust, which are being where sedimentation takes place, as well as there are parts of shoreline areas where different types of currents can be observed, like littoral current, sublittoral current, etc., etc. And depending upon them, there are also some geomorphological features those develop around the ocean continent transitional shelf area or ramp area, etc., etc. However, the oceanography mostly deals with the current patterns and the behavior of water by the interaction of the water with different types of forces which play or interact with each other. One of them is Coriolis force, and one of these is surface wind creating the Ekman spire to the depth of the water. The other forces or the other sources those create gradient in the oceanic water are thermal, or because of the salinity difference. These things actually are interdependent, as well as they create the circulation patterns of the oceans. Now, if we see that more or less, if I try to draw a circle, and if I say that is the Earth and it is an equatorial plane, there are different latitudinal lines, like suppose this is 30 degree, this is 60 degree, and this is 90 degree, or southern hemisphere, there is also 30 degree, and there is 60 degree, and there is 90 degree. And Earth, as we know, it rotates, as well as during the rotation there should be a role of the centrifugal force outside of the, or whatever the particles or whatever the materials on the Earth should face that centrifugal force. On the other hand, with respect to the reference frame of the Earth's crust, the oceanic water column obviously are different, because they have different property than the crustal rocks, and as a result, in the northern hemisphere, some of the, if you try to move a material, or if you try to use a material, the material will try to shift towards east, and this shift in the direction, or the right hand side direction, and this shift in the direction, if analyzed in terms of the vectorial fields, as an example, a small water column, this deflection or this force is known as the Coriolis force. And on the other hand, in the southern hemisphere, the material or the column is deflected towards left. And as a result, most of the cyclones or the storms which we observe in the northern hemisphere or southern hemisphere, we see that there is a circulation pattern. In case of northern hemisphere, it moves like in an anti-clockwise fashion, and in southern hemisphere it circulates in a clockwise pattern. And whenever we are trying to observe these oceanic gyres, or whatever the name is or whatever the thing is which we try to tell in terms of a geostrophic force. Geostrophic force is the latter portion, which actually results from the different forces interacting in the oceanic water column or current. The second forces which actually affect the movement of the water columns in the oceans, that happens by the drag of the air, and as a result, in an ocean, what happens, the water columns, whenever we try to analyze the velocity or the vectorial components of the water column to the depth, we see a spiral pattern, and the spiral pattern is dependent upon a physical equation which I will tell you, and those spiral patterns are known as Ekman spires because of the interaction between, suppose, the velocity of the air or as well as the Coriolis force or Coriolis pattern, and the equation that type of dominates the velocity is u is equal to capital U u naught into exponential of to the power minus of pi by d into cosine of pi by 4 minus pi by d into z. And this thing was actually derived by the Norwegian physical oceanographer who was named Sven Ekman. And the assumptions behind the solution are that the surface wind is uniform in both speed and direction everywhere, and ocean is of infinite extent horizontally. So water cannot be piled up in the downward direction to create an extra force in the form of horizontal pressure gradient, and this might complicate pattern. Also, the ocean, as it is infinitesimally drift, and in this equation the V is the U is the velocity component to the right hand of the wind direction, that is the small u. U0 is the speed of the water below the water surface, and which will be governed and which can be analyzed. D is the parameter that is contained or that controls the water density rho, the Coriolis parameter F, as well as the viscosity coefficient A. And D can be, we can replace the D value by the values of A, that is the viscosity coefficient of the water as well as the density of the water. much the if whenever the viscosity of the water column is high, then obviously the D will be high, and whenever the density of the water column is high, then the D will be lower term, and that will govern the equation. And what we find out from the equation is that, as well as another equation which takes into account V is equal to U naught into exponential of this terminology just gets change in terms of cos. In spite of cos, we get a value of sine, and this velocity component, which is taken as the velocity component at any depth in the direction of the wind. However, the earlier part or counterpart was taken into account the velocity component on the right of the wind. So obviously there is a role of the F value forgotten a term which is Z, that is the Coriolis parameter, and depending upon the, and D also depends upon the Coriolis parameter at a particular region or domain. Now what we might see from this equation is that with increasing depth or profiling, a vectorial component of the water depending upon the velocity of the air is generated, where we can see that water surface, the velocity is directed at exactly 45 degrees to the right of the wind, and with depth the direction of the velocity swings further and further right, while the speed falls off exponentially. And this figure or this solution is known as the Ekman spiral, or the, with the velocity of the wind and the superficial current, we can see that there might be changes in the net transportation of water as well as in the direction. Obviously the roles are like, we can see that depending upon the Coriolis force, this whole Ekman spiral is controlled. Over the top of that, there are roles of thermal gradient as well as salinity of the oceanic water, which determines the role of, or the vector of the water flow component. And because of these things are acting in a coexisting fashion, or rather interdependent fashion, there will be obviously a role to generate the gyres or the patterns over the oceanic realms. Suppose around the coast of Northern America, and there are certain spires which are dominated by these types of circulations. However, in case of Southern Hemisphere, this is moving like this, and this is the equatorial plane. And these currents obviously are capable to move some of the nutrient rich water to the cooler regions, and then these, whenever it is going back down the water, there is a carriage of different types of nutrients in the water, as well as generation of the oxygen, as well as the differences in the partial pressure of oxygen, and etc. etc. There is a certain current which flows from the Arctics to the much warmer parts, and these patterns, if you observe, these are also controlled by the Coriolis force and small scale, as well as some of the upwellings from the deeper parts of the ocean realm, oceanic realm, are being controlled by the Ekman spire. So that's how the whole oceanic network acts. So this is how we are going to analyze the oceanic circulation patterns and their effect on different biological as well as non-biological entities in the world. So thank you very much for listening to this short lecture.